Welcome to the AIRISE SME Experiment Series. In this video, we'll explore how Greek SME I Know How partnered with AIRISE in the RobnAI experiment to overcome challenges in scaling production from design to manufacturing.
Hello, my name is Marina Papakristopoulou. I'm a mechanical engineer with an experience in the industry the last 10 years. In the company, now I'm responsible for the business development, creating novel robotic products, proposing ideas and bringing them to life.
Hello, I'm Andreas Avourdos. I'm a mechanical engineer experienced in mechanical design and manufacturing of various products and assembly lines. And here in I Know How I work as a mechanical design engineer for the robots, so we study, design, and manufacture.
Okay, welcome everybody to the AIRISE experiment. One of the experiments which conducted was the RobnAI experiment, which we conducted together with I Know How. And we would like to have this final evaluation meeting with the company's representatives, just for you to get to know what the experiments conduct, how they are being done, and what we have learned from it. So welcome to all. So first, a warm welcome to the I Know How people, and maybe Marina and your colleague, you can introduce yourself.
Hello, very nice to be invited in this final interview section, and we are very glad to have participated in the RobnAI experiment for AIRISE. We are a company, I Know How. We're a Greek SME. We were founded in 2002, and we specialize in the development of software, health solutions, digital automation solutions, and robotic solutions for the public and private sector. We ourselves, we belong to the innovation department, which is developing robotic solutions and automation solutions for the past 10 years, where we advanced robotic systems to solve complex problems using AI, sensor fusion, and automation technologies. So during these years, we have developed more than 8 robotic solutions and have participated in more than 20 European projects. And I Know How is not only experienced in research projects, but has managed to bring into the market 2 of our products, commercializing them and having our first customers.
Well, thank you for the introduction of the company. And I was curious to know which specific challenges or pain points you could say were identifying yourself as being interested in bringing in an AIRISE experiment, and how did you get to know AIRISE at all?
So we have realized in our operations that the use of AI in product design is one of the less explored topics in the industry, especially when talking about creating sustainable products. So in our efforts to keeping track with the AI and including it in our processes, we came across AIRISE open call, and we saw the potential of having AIRISE as a potential partner to address some of the most common challenges in the design process. That is, how do we ensure that our robots are designed, produced, and later retired in the most cost-efficient and less complex way? Talking about life cycle assessment and sustainability, sustainable designs. So in this open call, we found ourselves very suitable to participate, especially seeing the design and engineering AI services topic. It seemed ideal to facilitate our strategic goal to transition into incorporating the AI into our design process and support our engineers in the whole process from design to final production.
Could you describe the main product or solution AIRISE helped you to implement, and could you also indicate what the intended business outcome was?
The scope of the project was to improve the design process of our robots by incorporating AI in order to create robust, cost-effective, and sustainable products. So AIRISE gave us the tools to include geometry and topology optimization methodology into our design processes. So we focused mainly on two specific use cases, two components of our robots that were intended to reduce their mass, their cost, and shorten the design time and manufacturing complexity. The first component was from a logistics robot that supports the assembly line established in our facilities. The second component was from an underwater magnetic crawler, which removes biofouling from ship hull surfaces. One of the most important requirements for both our robots is the optimized design for these parts in order to achieve a maximum strength and minimum mass. With geometry and topology optimization, we aim to generate ideas for the design of the parts, taking into consideration the sustainability of the final designs.
So to continue with the business outcome, the intended business outcome was to employ our engineers with valuable tools to use AI and help them create better designs in shorter period times. So that would lead to less manufacturing complexity and delivery time, having an overall added value, satisfying our customers, decreasing the overall cost of the robot, and having better business this way.
At the start of the project, what were your initial expectations from integrating AI into your processes or services?
At the start of the project, we wanted to explore the possibilities of integrating AI in various ways into the design process, but we didn't know exactly how this could be facilitated, which was later specified together with our tutor and with Amen services. So our initial expectations were indeed related to cost reduction of the production of the parts and create better and stronger alternative designs, which would of course have sustainability in mind. So in general, we wanted to develop a methodology that our engineers could follow during the design process and which would assist them throughout the whole creation, increase also their satisfaction and easiness of use, cutting down the design time of the parts using AI. So from the side of the engineers, their expectations were as indeed facilitated. They were familiar with optimization of topology optimizations and AI into the design process, and they were actually finally able to integrate it in their own procedures.
What have been the most significant benefits your company has experienced from the use of AI in terms of efficiency and also overall business value? Can you point on that?
Our engineers assessed that the geometry optimization tools gave a user-friendly experience and generated design alternatives that overall improved the design, manufacturing, and cost of the specific components of the robots. The benefits of using AI included a significant reduction of 50% for the mass of the target components, while preserving the structural integrity. We also achieved a reduction of 65% for the production costs of some specific alternatives, and also a massive decrease in the design time of certain components, since most optimized geometries were now generated by AI. Overall, this is a great value for the company, since we can reduce the design time of the robots, especially when focusing on the optimum design of specific parts, which is often required in the versioning of the robots, where improvements need to be made.
Can you share any specific examples of how AI has enhanced your operations or customer service? Can you tell us about that?
So in the end, customer service has become more efficient because the manufacturing complexity of the robots has decreased of certain parts, of course, and therefore there are less steps in the production phases, minimizing the risk of delays and endangering the delivery of a project.
What were some of the anticipated challenges you expected during AI implementation? And were there also unforeseen obstacles that arose during the project?
So our anticipated challenges during the implementation of the project were related mainly to geometry modification, where using Blender would be not produce satisfactory output models, and interaction between different software would be some kind of problematic, which was not actually a problem, and outputs were good based on the parts that we provided, and we selected the appropriate file extensions. Furthermore, we anticipated that there would be challenges with the generated solutions, and that would not be feasible to manufacture using material forming or removing methods, and that the models would have to be redesigned to become manufacturable. There were no other unforeseen obstacles that arose during this project.
How did the AIRISE team help you address these challenges, and which strategies were most effective in overcoming them?
The AIRISE team introduced us to ways of utilizing tools that account for the manufacturing method of components, whether they are to be produced using CNC machining or additive manufacturing. By using Fusion 360, we could consider alternative manufacturing methods, and the model would be updated automatically instead of having to manually redesign it. This approach makes it considerably easier to integrate these techniques and generate designs that are suitable for manufacturing without requiring significant design modifications to be proposed solutions.
AIRISE provides several services, as we all know, and are the specific services or tools provided by AIRISE where you think they're most useful to your company, and how did they contribute to the success in your AI initiative? Can you tell us about that?
So the customized tool that was developed by Ayman in Blender was very useful, since we could easily generate optimized geometries and then use these in our simulations. Additionally, the training that we received also on Fusion 360 with its topology optimization and shape generation capabilities was also very useful to explore the integration of this tool into our design processes in the future. And all the above tools served us to achieve our KPIs that were set at the beginning of the experiment to have a success in our project. So to generate basically designs of the components with reduced mass without sacrificing their strength, and to greatly then reduce the manufacturing complexity and time of production of the components, and achieve then lower manufacturing costs and eventually a smaller price for the for the robot.
Looking forward, what are your future expectations regarding the continued use of AI in your company, and how do you see AIRISE contributing to your long-term goal, if any will, right?
So we will continue to use the tools provided to us for complex parts to achieve a reduction in mass and manufacturing costs, especially for parts that are potentially suitable for additive manufacturing. Topology optimization and generative design can also be very useful to generate ideas, even when additive manufacturing will not be the selected method. As additive manufacturing technology continues to evolve and the range of available materials expand, the potential for leveraging AI in the design process becomes significantly greater. So, as a long-term goal, the AIRISE experiment can ultimately contribute to our long-term goals for producing robots in a sustainable and cost-effective way, and improve the decision-making during the design process of our company.
Has your perspective on AI changed since partnering with AIRISE? And what advice would you give to other businesses and companies considering AI consulting services? What would you tell them to do?
I've always had the positive view of using AI tools in conjunction with suitably trained users. Mechanical design is one of the fields that is significantly evolving through the integration of AI tools and modern methods of manufacturing. numerous companies have successfully incorporated AI tools into their design process, resulting in a significant reduction in design time, substantial improvement in the characteristics of produced components, and ultimately a decrease in overall cost for the company. Therefore, I would recommend the use of AI tools, particularly those related to finite element analysis, topology optimization, and shape generation.
If you would describe your AI journey with AIRISE in one word or phrase, what would it be and why? Curious to know.
Okay, I think that the overall journey with AIRISE, it's creative and informative because the optimization tools that were used are not part of our routine tasks, and they represent the most modern technology available for the product design process.
It was a great journey to have our tutor and Eamon as our consulting services to support us in integrating AI into our design process. In general, I would say that our engineers managed to see some innovations in the sector and actually facilitate what they have been seeing happening in bigger companies. So it was actually a very nice and beneficial experience for us that will also help us in the future to develop more processes like this. We definitely proposed the AIRISE experiments and the pilot for companies to undertake because it's a very good opportunity to see the developments of AI and the integration of AI in the design of products, simpler and more complex. We're actually very interested in this new open call, and it would be the ideal evolution of the project to be able to implement some ideas we had, which because of the limitation of the 6 months were not able to be facilitated. So it will be under our strategic goals, I think, to apply also for this call. We are actively integrating AI into the process of designing robots. What's cooler than that?
Thank you for joining us in exploring the innovative experiments of the AIRISE project. To stay updated and learn more about our journey, subscribe to our social media channels and visit our website at airise.eu. Together, let's shape the future of AI in manufacturing. This project is funded by the European Union